Hello everyone. We all use a smartphone functionality using a touchscreen without any need to know how it is working internally and allowing to perform actions with just a simple touch. We also use a different apps to call, to send messages, to chat, and also to connect with the internet without need to know how it is processing our request internally. That is what exactly called as abstraction. It means that hiding the complex implementation details and expose only what is necessary to perform the actions or to interact. As we saw in the video, abstraction helps in hiding unnecessary details and exposing only relevant functionalities. It focuses on what an object does instead of how data is stored or processed. The example in this image, we as a user use our smartphone using just a touchscreen without need to know how that touch is handled by the complex system in our smartphone like software code, circuits, processor, chips. This is abstraction. Let's understand about abstraction in more detail in next slides. Let's understand using an example in a Java code. So this is a payment parent class which have this make payment public method, right? And it is exposing only the essential part. So, but if we see in a make payment method, there are two private or the protected methods which are actually doing the validation and payment processing logic. So, let's say there are two classes, credit card payment and PayPal payment, which are extending this payment base class. And they are writing their own version of process payment class, their own logic of processing the payment. So when the child class wants to write their own logic for the method which is coming from the base class, they can use this override keyword. Now, when the user makes a payment, it will come to our main class and interact with our system. User doesn't need to know whether how the credit card payment processing is happening, how the PayPal payment processing is happening. That logic is something internal, right? And that is hidden from user. User can just interact using just a make payment method, right? So this is a abstraction. Now when we see this example, we can say that these methods are hidden using the private or protected access modifier. This looks like an encapsulation. You are right. Here encapsulation is helping in a one way to achieve the abstraction, right? But abstraction and encapsulation are two different things. Let's understand that. Abstraction hides the complex implementation details and exposes only the necessary functionality, like smartphone touchscreen. Encapsulation, it hides the data within the class and ensures controlled access using methods. So encapsulation works towards data hiding or data security to maintain the data integrity. Abstraction focuses on what an object does, but encapsulation focus on how the data is stored or handled to protect it using a different access levels. Let's take an example of bank account. The bank account class defines a general structure, deposit, withdraw, get balance to interact with the bank account, but does not define how they work internally. The balance details or the data in a bank account is a private, and we can only modify it using the methods or the operations of the bank account using deposit and withdraw. For example, user calling a withdraw method without knowing how the funds are deducted internally, without knowing how the balance is stored, right? So withdraw acts as a way to interact with the complex implementation detail to deduct the money. But encapsulation means that user cannot directly modify the balance. They can only do that using deposit or withdraw operation. So we understood the difference between abstraction and encapsulation. Abstraction mainly works towards hiding the implementation complexity of the system, and encapsulation works towards the data security using controlled access using different access levels. Abstraction in action. So different languages achieve the abstraction using different ways. So we'll understand how the abstraction is achieved in a Java. In a Java, there is a concept called abstract class, which can be used to achieve the abstraction. So what is abstract class? Abstract class is a class that cannot be instantiated, means you cannot create the object of abstract class. It can be used by inheritance by subclasses, means that without inheritance, abstract class is of no use because we cannot create object of it. Abstract class contains abstract methods and concrete methods. Abstract methods means methods without body, and the subclass who are extending or inheriting this abstract class needs to implement this abstract methods. Concrete methods means there will be methods with some implementation, some logic. Let's understand with the example. So here there is abstract class payment, which contains the abstract class can contain the instance variable or different types of variables. Here amount is the instance variable, or we can say object variable, and it also contains the static variable. You will notice here there is a constructor. Though we cannot create the object of abstract class, the subclass who is inheriting that abstract class can call this constructor to initialize the variables of the abstract class, or the variables which are defined in the abstract class. And this is the abstract method which we need to implement in a subclass. So it is forced to implement. For example, credit card payment, which is extending the payment abstract class. You can see the override keyword here. It means that it has to implement the process payment in it and add its own processing payment processing logic. And you can see from credit card payment constructor, we can call the abstract class constructor using super to initialize the instance variable. So we achieved the abstraction using the abstract class, where we can keep the common variables or the methods, and that can be extended by the subclasses. Now, when to use the abstract class? When we need to have a base class with some common behavior, right? But one point will come, then why do we need to have the abstract class only, right? The point is that when we want to have some class which will enforce the subclasses to implement the certain methods, right? When we use the general base class without abstract class, then we cannot enforce, right? But abstract class enforces the subclasses to implement certain methods, which are abstracted methods. And abstract class also provides capability to reuse some methods like concrete methods, right? So it's a combination of, we can reuse the concrete methods in that abstract class, and we can also enforce the abstracted methods to be implemented by the subclass. So when we need this kind of a functionality, the abstract class is the best way to achieve it. Another way to achieve the abstraction in Java is the interface. In a previous video related to the inheritance, we understood what is interface, but let's quickly recap. So interface in a Java is a blueprint or a template for a class that contains only abstract methods and default or static methods. So when we say abstract methods, means that it is just defining the methods, and the class who is basically implementing that interface, they need to provide the implementation, right? Means interface will just act as a contract or just a template which will have the method definitions, right? No implementation. And the classes who are implementing that interface needs to provide the implementation of those interface methods. For example, here we have defined the interface payment with the process payment abstract method, no body. Now, when any class like credit card payment and the PayPal payment, when they implement this payment interface, they will have to override and provide the implementation of this process payment abstract method and add their own processing logic. Now, using this interface, the payment, we can call the process payment method, and based on the object reference which is stored here in payment one, the object reference is credit card payment. So it will call this process payment in the credit card payment, and in the payment two, the reference is of PayPal payment object. So it will call the process payment of PayPal payment class. So this way also we can achieve the abstraction and put the process payment or the common behavior at one place, and whoever wants to interact with these different types of payment methods, they can interact it using the interface and the abstracted method or the common method defined in that interface, like payment interface and the process payment method to interact with this payment classes. When to use the interface? When we need 100% abstraction. As we said, interface is just a template which provides the method definition, and subclasses needs to implement all the method. So when we need to have this kind of 100% abstraction, means enforcing all the subclasses to implement certain types of methods, then we can use the interface. When we need to enforce the common behavior across unrelated classes. For example, let's say we have this notifiable interface, which have this send notification. But this send notification method can be written in email notification or SMS notification. Now, when we want to send notification using email or SMS notification, using the interface notifiable, they can call to the send notification. So outside world, it is abstracted using the interface. They can interact using the interface and send notification method. And based on the object reference, they can call the email notification or SMS notification, right? So this common behavior of send notification can be achieved using interface. Loose coupling and flexibility. So if we see here, payment interface will have a pay method. There are two classes, credit card payment and PayPal payment. They have their own, they are implementing the payment interface, and they will have to override their own and have their own pay logic, right? The pay method, which is there in interface. They are enforced to implement that pay method. Now, let's say there is a shopping cart class, like for example, similar to Amazon. When we do the checkout, it will do the payment, right? Now, here in this, if you see the constructor of this shopping cart, we are passing the payment interface, right? So outside world is interacting based on this payment interface, right? And whatever the object reference stored here, like let's say here credit card payment object reference is stored. So automatically during runtime, it will call based on the object reference, it will resolve that it needs to call this pay method of credit card payment. If tomorrow the default payment method, let's say if user selected the PayPal, then automatically that payment method will have the reference of PayPal payment. But this logic of shopping cart will not change, right? Because it is just calling it using interface. And PayPal payment also have implemented the payment interface, right? So during runtime, based on the object reference, it can call the pay method of PayPal payment now, right? So we can see there is a loose coupling and flexibility here. Without making much changes, we can shift the payment method easily using the interface. Right? So that is the abstraction capability. Now let's understand the difference between abstract class and interface. When we want to provide some common behavior to the subclasses, not just methods, but variables, some concrete method, right? Then the abstract class works nicely. Interface, when we just want to define some contract and like define some methods, and which we want every class who is implementing that interface to implement. So when we need such contract, then interface is the best way to go. When we want to enforce a base structure, like having some class where we will have some default logic also, but we'll also have some methods which will be enforced to the subclasses inheriting that class, right? Then that base structure can be easily implemented using the abstract class. When you need a multiple inheritance, because using class multiple inheritance is not allowed in Java, but using interface it is allowed, because interface using the interface we can easily resolve that, because interface is just a contract, right? And which method to call is gets resolved during runtime, right? As we saw in a previous slides example. Or abstract class can have an instance variable. So when there is a requirement to have some common code uh, where we need to define the instance variables, then abstract class can be useful. Interface does not basically can have variables, but those will be static or constants. It can have a method with implementation, concrete method with some actual logic, right? Interface methods are abstracted, but recent Java versions have a capability to define the methods logic also, but that will be default or static methods only, right? So this is the difference between the abstract class and interface. So we understood about what is the abstraction, the concept of object-oriented programming. What is the difference between abstraction and encapsulation? Different ways to achieve the abstraction in Java using abstract class and interface, and their difference between the abstract class and interface. In a different languages, the abstraction can be achieved in a different way, but mostly the basic will be it can be achieved using the abstract class or the interface only in most of the languages. But as a base knowledge, abstraction is very important or core concept of object oriented programming, which helps us to increase the code maintainability by making the code simple and making it more flexible, uh, to basically hiding the implementation detail easily, right? So hope this video explained that concept very well. And if you like the video, please share and subscribe. Thank you so much.